We have looked at addition, subtraction, and multiplication of complex numbers. Probably the most difficult of the operations that we're going to do is this one, which is division. So when we divide two complex numbers, remember the goal is to get something in the form of a plus bi, not a plus bi over c or a plus bi over ci. What we want is just a number plus and minus a number I with nothing in the denominator. So what we need to do is we need to look at this division sign. Okay, so remember fractions are division. This is 2 plus 4i divided by 5 minus 7i. We need to look at this and decide how can we make the bottom like just go away? Well, you can't just cross it out. But what did we learn? We learned that if you multiply a number that is complex by its conjugate, your answer will be a real number. And then we can use some stuff that we learned earlier to turn it into a plus bi form. So the trick here is that if you're going to divide two complex numbers, you have to take the bottom and multiply the bottom by the conjugate of that bottom. Now, here's where students get in trouble. If you do something to the bottom of a fraction, if I multiply the bottom, like let's say we have 2/5, and I multiply this bottom by 3, what do I have to do? I have to multiply the top by something. Well, can I multiply the top by 5? No, I have to multiply it by exactly the same thing, which is 3. That'll give me 6 over 15. That is a legal thing to do with fractions. So if I'm going to multiply the bottom of this complex number by 5 plus 7i, then I have to multiply the top of this fraction by the same complex number, 5 plus 7i. Notice this is not 2 minus 4i. It's not the conjugate of the top. It has to be exactly the same thing as the bottom. Exactly the same. So take the bottom, find its conjugate, multiply the bottom of the fraction by that conjugate, and whatever I do the bottom, I have to do exactly the same thing that I multiply by on the top. Now, what you'll see here is that this is a little bit messy because now I have a multiplication that I have to do on the bottom and a multiplication that I have to do on the top. Most of my students do a pretty good job of recognizing that we have to multiply out the two complex numbers on the top. And that will get something like this. But a lot of my students is stuck in this idea that, well, if I did whatever I did on the bottom, it's just going to cancel. No, 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 no. There's no canceling here. What you have to do is you have to multiply it or FOIL it out, and you have to do the math. It's not as easy as it just cancels. And it would be nice, but that's not what happens. So if we multiply out the two complex numbers on the bottom, let's see what we get as we sort of start to simplify. So on the top, remember, you can combine like terms. So that'll give me 10 plus 34i plus 28. And what is I squared equal to? -1. So we've got a little bit of simplifying happening on the top. Now let's be careful with the bottom. If you look at this, the -35i and the 35i are the same, and those will go to 0. But is the 25 and the 49, do those cancel? No, they do not. They're not the same thing. So the bottom doesn't just disappear. You've got to do the math. So we're going to do -49. And what is I squared? -1. Notice these are multiplied, so these are multiplied, right? So as we continue to clean this up, we're going to get 10 plus 34i minus 28 on the top, and then 25 plus 49 on the bottom. Now, one more thing on the top will collect like terms. That gives me -18 plus 34i. And on the bottom, we're going to get 74. Now, A lot of students want to stop here, but remember your answer must be an A plus BI form. And what did we do at the very beginning of this unit, of this section? Is this standard form? It is not. How do I take that one little denominator number, which is just one little real number, and make this so that we're in A plus BI form? Well, remember, we uncommon denominator it. That's what I called it. So we can sort of think backwards of addition of fractions. We can take that denominator and put it underneath each of the numerator numbers. Once that's done, we can now reduce these fractions down, and that'll give me negative 9 over 37 plus 17 over 37i. And there is my final answer. A lot trickier than it looks, right? Okay, so let's look at this next one over here. We have 2 minus 3i divided by 2 plus 4i. Notice it's written a little bit differently. If it's written like this, I don't like working with things that look like this. So the first thing I'm going to do is make this look like a fraction. So remember, division is just a fraction, top divided by bottom. So I'm going to start by writing the number in a fraction mode. And then what's the rule? I multiply the bottom by the conjugate of the denominator. So we're going to do 2 minus 4i in the denominator. And I have to do exactly the same number on the numerator as I did multiplied on the denominator. This is not 2 plus 3i. This is 2 minus 4i, the same number on the bottom as on the top. And now we're going to do our math. Does the denominator just cancel? Can I just do that? No, I need to FOIL and I need to multiply. So on the top, we'll get 4 minus 8i minus 6i plus 12i squared. On the denominator, we'll get 4 minus 8i plus 8i minus 16i squared. And notice the only thing that even remotely looks like it's going to cancel are the two i's on the bottom. Negative 8i plus 8i is 0. And they don't even really, like, the bottom doesn't cancel. It just eliminates that I in that manner. Now, cleaning this up a little bit, we get 4 minus 14i plus 12, and then I squared is negative 1. 12 is times I squared, so 12 is times negative 1. And then I squared is negative 1 again. So when we kind of put all this together, what do we get? We get, okay, 4 minus 12, that would be negative 8 minus 14i. And in the denominator, negative 16 times negative 1 is positive 16 plus 4 is 20. Is this standard A plus BI form? It is not. How do I fix that? We uncommon denominator, and we means we're going to put that 20 under all of the terms from the numerator. And then we will reduce our fractions. So 8 over 20, let me see, those are both divisible by 4. So we'll get 2/5, and 14 and 20 are both divisible by 2. Now, a little note. Remember, we want to always put the I after the fraction. Don't put it in the numerator. My open math will count it wrong if you put the I in the numerator. So just keep the I at the end of the fraction, and there's our final answer.